Hi everyone, my name is Gidenzi Wonga and I'm working in STS Badakubi as a science teacher. So today I'll be taking the class 9 chapter number 8, that is motion chapter of science textbook. So today our learning outcome for this session is what is motion and what is the distance, what is the difference between the distance and displacement. So we will go through that. Yeah. So generally, when we talk about motion, every one of us, we have some rough idea about what actually is motion. Because any object which moves, we used to consider that as a motion. So I expect when I ask the class, every one of you must be having some rough idea about what is motion. But it is very important for us to have a very exact or a very precise definition of a motion. So in order to understand that, first we should be having a brief understanding of what is rest. Rest here. So I'm going to write a diagram here. Okay. What is this? This is a table. Okay. Okay, so through this picture, what I am trying to ask every one of you is that there is a bowl of water on a table. So now, if that particular object, that is the bowl of water, with respect to this particular table, if this bowl of water is not changing its position, because this is the position number A and this is the table itself, right? So if the position of the A is not changing with respect to this particular table, we used to call this kind of like situation as the object is at rest. Understand? For example, I will give you another one. There is a tree here, and there is a rock here. Okay? This is the position number A and this is the position number B. Now if this particular rock is not changing its position with respect to this tree, we used to say that this particular object is at rest. So generally, how we define rest means any object which do not change its position with respect to a reference point. So I'm mentioning here a very important point, that is a reference point. So let me just write first. So this is how we define rest. An object is at rest, right? Okay, so now if an object is at rest, the opposite thing for this is the object in motion here. So our topic today, we are going to learn about motion. So now if we are going to learn about motion, we have to go exact opposite of this particular thing over here, right? So as I have written over here, any object which do not change its position here, with respect to a reference point. Reference means you are going to refer. For example, let's imagine here, there is a house and there is a sleeping dog. This is a sleeping dog. Let's imagine this is a sleeping dog. Okay? This dog is at position of A and this is at position of B. Now, from my point of view, this dog, it depends on how I'm going to take the example. For me, I'm going to take the dog in a dominant factor, so I'm going to take this house as the reference point for the dog. So if this sleeping dog is not changing its position with respect to B, we call this sleeping dog is at rest. Do you understand? So this is what we used to define as rest. Now, if we go for the motion, motion means with respect to the reference point, an object has to change its position here. For example, let's imagine this is the blackboard and I'm standing over here. If I'm not changing my position with respect to the blackboard, you can say I'm at rest. But this is a blackboard and I'm standing over here. If I'm changing my position from here to there, you can somehow say because I am in the process of motion here. So this is what we used to define as motion here, motion. Motion. Any object which do not, now this is not the do not thing here. Any object which changes over here, which changes its position with respect to a reference point is referred to as motion. So we have so many different kind of examples in the case of motion. For example, we can have the fan moving, the blades of the fan moving from one position to another position here. You can see me standing from this position number A to position number B also. This is a motion here. And you can also have another example of a bike which is moving from A to B, position changing there, right? For example, I'm going to give an example of a person who is running. Okay? Now this person is using some of his energy to run from position number A to position number B. Right? Position number A to B. Now if he runs from A to B, we are definitely sure that this particular person is going to change his motion after a few minutes, after a few seconds. He is going to change his position from A to B here. So there is a change in position. In that case, we used to call this as motion. So this is about the motion which we are going to study in this chapter. So generally when we talk about motion, this is not the first time we are learning about the motion. Previously in class lower standard also we talked about the motion. Like there are three types here, right? Number one is linear motion. Circular motion, number two. Oscillatory motion. Okay, so if I just give an example in the case of linear, circular, and oscillatory motion. Linear motion, during inter-house school athletics meet, we have 100-meter race. 100-meter race. Okay, I guess every one of you are quite aware of that. So if I was asked to write down the diagram of track of the 100-meter race, I have to write in that point here. I'm really sorry for my very poor in writing the diagram here. Okay, this is my track. Okay, so this particular person, he has to run straight in a 100-meter race, right? Let's say this Sonam. Sonam cannot run in that manner here, zigzag way, right? He has to run in a straight way in order to finish the 100-meter race. So these kind of motion where a particular object travels in a straight line, that is a linear kind of motion, we used to call this as linear motion, right? Now the second one is circular motion here. Circular motion. Circular motion is, we can take the example of clock, right? Clock. In clock we have, minute hand and second hand. Let's take an example in the case of minute hand. This minute hands, from one center point, it has to cover some sort of distance here. and finally it will come to his own original position, and it keeps on repeating. It's such kind of motion which moves in a very circular way. We call this kind of motion as circular motion. I can also take the example of a person who is having a rope, and this rope is tied to a stone, and he is rotating it, right? So from one center point here, this is a point, one center point, this rope is moving. Such kind of motion in a circular way is what we used to define as circular motion. Now the last one is oscillatory motion. Generally, oscillatory motion means oscillation, that means back and forth. Any kind of object which moves in a back and forth motion, we used to refer this kind of motion as oscillatory motion, right? Back and forth. Or else you can also take the example of pendulum here, pendulum, right? Pendulum. Because normally in the case of pendulum, they move in toward and forward motion. This kind of motion is what we used to call as oscillatory motion. Suppose, imagine, okay, you have a rope, and to this rope you have a little amount of stone tied to the rope, and from this point you're going to stretch this particular rock to this point here, and you're going to release it. When you release that, what will happen? This particular rock will move in that direction here, and it will go back. Then it will come back, it will go back. As soon as the amount of energy in this particular rock and thread finishes, this particular object or the bulb, it holds to that position over here. This kind of motion where the object goes in a backward and forward motion, we used to call as oscillatory motion. So I guess you all are having a little amount of idea about oscillatory, circular motion and oscillatory motion in the lower standard. But in this particular chapter of motion, we are going to focus more on linear motion here. Is that clear? So let's go for linear motion. Okay. So generally, when we talk about motion, one thing that comes to our mind is that when an object moves, it covers some distance, right? So the point here, the first thing which we are going to talk about is distance. That comes to our mind whenever an object covers some, moves from one position to another position. So we used to say that if an object moves from one point to a certain point, let's say point B, we can somehow conclude that he is covering some sort of distance here. So generally, let's imagine, okay, there is a person, right? And his name is Tashi, let's say, this is Tashi. Tashi covers a distance walked from position A to B. Then suddenly, he found that this was not the actual route he should be going there. So he has to change his route from B to C. Then all of a sudden, Tashi somehow, came to know that the route is exactly in the same way which he should be going in. So what he did, he made a U-turn over here, and he came back to this region over here, and he went over here, and he met his person over here. Now, there is a A to B, B to C, C to D, and D to E. Now, suppose, imagine, okay, I'm going to keep that as 10 meter, and this as 5 meter, and this as 1 meter, and this as 5 meter exactly, this is 5 meter again. So now, generally, what is distance? Distance means the length. We know length. Distance generally means the length. What length? The length of the path or the route that person, Tashi, has traveled from A to D, A to E. That complete pathway is what we used to refer as distance over here. For example, listen here. Now this is Tashi covered from A to B. That means he covered 10 meter. Then suddenly 10 meter he went to over here, that is 1 meter on top there, that is C. 10 plus 5 is 15, and 15 plus 1 is 16, plus 5 is 21, 21 plus 5 is 26. So the total distance traveled by Tashi is 26 meter. This is how we calculate distance. So generally, what is distance? It is the length, or I should say the total length of the pathway. Total length of the pathway is referred to as distance. And this particular distance, the second point in this case, it has to be measured always in the form of meter, right? I'm going to write here. Okay, so second point here, whenever we are measuring the distance, the standard unit for measuring the distance is meter, that is symbolized by m. Now the third point is distance can be positive and distance can be 0, but it can never be negative, right? So now I'm going to create a scene here right now, okay? In that scene, there is a girl. Let me just write here. There's a girl. Okay. So there's a girl. She has a dog. It looks like a sheep. Okay. Now it doesn't matter. This is a dog from my perspective. So let me just name this girl as Tukden. And she has a dog. Dog name is Sirin. Now what happened one day, Tukden lost Sirin, right? Now Tukden was in a desperate situation that she has to find her own dog, that is Sirin. So she searched here and there, she couldn't get any kind of information about Sirin. So now what she's going to do? She was just crying in her own room. So what happened? Okay, one of her friends called her, Tukden, I found your dog. He was traveling, like he was curving a certain kind of distance. Let's say Tukden's dog was curving a certain kind of distance, like 20 meter. He is curving a distance of 20 meter. So if somebody asks you, if somebody tells you like, your dog, I found a dog and he's covering a distance of 20 meters something, there is nothing kind of like specific information about where is your dog. Though the dog is with your friend, but if you get a particular kind of information that your dog is covering a distance of 20 meters, that's it. Because whenever we talk about distance, okay, we never disclose anything about the direction in which we are talking about, right? So let's say Tukden got the information, right, like sitting covered the distance of 20 meters. Now what she might be thinking, Tukden? 20 meter where? That's the point here. 20 meter. 20 meter in this way, or 20 meter in that way, or 20 meter in this direction over here. It could be possible. Any kind of like thing. So generally, when we talk about distance, for example, okay, if I say I covered a distance of 200 meter. In my case, I covered a distance of 200 meter. So what you will think now? 200 meter where? In forest, in towards the mountain, in water, where did you travel 200 meter? That is the point of concern. So generally when we talk about 200 meter distance, we never mention anything about the direction. So when we talk about distance, there is no direction at all. Is that clear? Because in distance, there is no direction. That is why they belongs to a certain kind of quantity, which we are going to discuss in the next one. Okay? So that is number 4. No direction. So these 4 important things, like it is important for you to understand is, that is the number 1 is the total length of the pathway is generally defined as distance, and it has to be measured in the form of meter, but there are certain kind of other units, bigger units like kilometers and all of this. and distance can be positive, can be 0. For example, in my case right now, I'm not changing my position here, over here, so my distance is 0 right now. And generally when we talk about distance, there is no direction at all, right? Okay, now I hope you have understood anything, something about the distance, right? Okay, so let me go for the next one, that is scalar quantity. Scalar quantity, because just now we took the example of distance here. Distance, right? Let's say Thupten covered a distance of 30 meter, and you don't have any idea about direction there, right? Let's say I have traveled a distance of 400 meter. You don't know anything about the direction also again, right? And there is another one for speed. Speed. For example, okay, the fastest man in the world, his name is Usain Bolt. Usain Bolt, we used to refer there, though there are different kind of pronunciation there. So let's suppose, imagine Mr. Bolt, he ran the fastest sprint in the world at a speed of 9.69 meter per second. That's a lot of speed, right? Now suppose, imagine, this is just an example here, 9.69, 1 second, I don't know whether you'll be able to manage it, 1 sec is gone, 9.69, let's suppose, imagine. So Mr. Bolt, he covered 9.69 meter in 1 second. But Mr. Bolt is running in which direction? Did I say anything about the direction? Let's talk about another person here. There is two kind of person here. That is number one, this is Mr. Tashi here. And there is another person called Mr. Kunga, right? Okay, so Mr. Tashi is running at a distance, at a speed of like 30 meter per second, which is a huge speed. And Mr. Kunga is running at a speed of 1 meter per second, which is also a very good speed. Now, on the blackboard, I have, by looking at the diagram, you can somehow see in which direction he is running. But if I am telling you in my own way that Tashi is running at a speed of 30 meter per second, in 1 second 30 meter, you won't be able to imagine. He is a very fast boy, but you won't be able to understand in which direction he is running. Same case, in the case of Kunga, he is running 1 meter in 1 second. That means he is also running at a very fast pace, but you won't be able to understand in which direction he is running. So generally, when we talk about all this kind of thing, distance, speed, they belong to the same kind of category, that is scalar quantity. So generally, what is scalar quantity? Scalar quantity are those quantity which only shows the magnitude, but there is no direction in that. For example, magnitude in this case is 30 meter per second, right? Here, Mr. Bolt is running 9.69 meter per second. So in 1 second, Mr. Bolt is running 9.69. That 9.69 is a magnitude, but we don't know where Mr. Bolt is running. So when we think about that, generally in scalar quantity, there is the presence of magnitude. Magnitude is present, but there is no direction in that. No direction. No direction. So in that case, scalar quantity are those physical quantity where you can find the magnitude, but you cannot find the direction is referred to as scalar quantity. Is that clear? So we can also take the example of mass or some mass. The mass of an object is 5 kilogram. Which direction? I didn't talk anything about the weight, mass. The mass of an object is 5 kilogram. In which direction? No idea, right? So, but the 5 kilogram is the magnitude, but there is no direction, so it belongs to scalar quantity. So generally, when we define scalar quantity, how we are going to define scalar quantity are those physical quantity where there is a presence of magnitude but there is no direction. For example, distance and speed. Understand? Let's go for the next one. Okay. Displacement. Displacement is another form of distance. Understand? Displacement is another form of distance. Another form of distance. But it is not distance. So what is displacement? Generally, when we talk about displacement, we are concerned about two things. What is that? Initial position and the final position here. Initial position and number B is the final position. Initial position and the final position. So generally, okay, as we have defined already about the distance, distance means whichever route you are going to take. For example, I'm going to give another example here. This is your school and this is the home. There is a girl, her name is Nawam. Let's suppose, imagine Nawam goes to school every day in the morning at 7 o'clock. When Nawam goes to school every day in the morning, she covers a distance of 2 kilometers. Understand? 2 kilometers. But what happened one day was there was some kind of like a construction going on this part of the route. That means she cannot go. So what she has to do, she has to find some other route through which she can go back to the school. So what she's going to do, she's going to cover some sort of distance over here and she will reach. Now in that case, from here to there, she is covering a distance of 5 kilometers. Understand? So anyhow, in the second kind of like situation here, Nawam will take more amount of time to reach her school. In first case, faster, but in both the case, Nawam reaches school, right? The factor is more amount of distance and more time, and lesser distance and lesser time, right? So generally, when we talk about displacement, that means the initial position, initial, the word initiate. There is another kind of word called initiate. Initiate means start. Start doing your work. Initiate, kind of like a student movement from your class. Initiate means start, starting position. The starting position of Miss Nawam is her home. That is this. And the final position of Miss Nawam is school. Right? So now, in this case here, this route was not working and she's covering the distance in that way here. So now, since I'm going to consider from this part here, now I will ask you, okay, what was the actual distance covered by Miss Nawam to reach her school from her home? You are definitely going to say 5 kilometers. But in the case of displacement, we are concerned with initial position and final position. And the shortest distance between the initial and the final position is referred to as displacement. Do you understand? For example, I can give you another one. Okay, I hope some of you are not clear with this one. I will go for another example here. Let's look up over here. This is position number A, right? Travels to B, then to C, then to D, then to E, then to let's say F here. Okay. So now, generally, previously when we talked about the distance, it has to be from A to B, B to C, C to D, D to E, E to F. We have to sum up all of this and you will get distance. But in the case of displacement, we are not concerned about all the pathway, but we are more concerned about the initial position and the final position, and the shortest route between these two is referred to as displacement. So whenever you are mentioning anything about the displacement, there is always a direction in that displacement. Is that clear? So how do I define displacement? Displacement is defined as, I will write here, displacement is defined as the shortest distance between the initial and final position here. Understand? So in a similar way, like it is another form of distance, we measure in the form of meter. Understand? But the strange thing about the displacement is that they can come in the form of positive, 0, and they can also come in the form of negative also. Is that clear? So this is the beautiful thing about the displacement. And as we have discussed before, whenever we talk about displacement, there is direction. There is direction, right? Okay, so in the next class we will talk about positive, 0 and negative, why displacement is positive, why it is 0, and why it is negative, right? So before I wind up the first session today, I would like to give you one question. Okay, the question is, whenever you are riding a taxi, right? Whenever you are riding a taxi, you get charged. Let's say if I wanted to travel, okay, in a taxi, I have to pay some amount of rupees, right? For example, like 100 rupees for riding in an auto, in a taxi. Now my question is, on what factor, like distance or displacement, on what factor, distance and displacement, you get charged in a taxi? Do think about that. I hope you will get the point here, right? So whenever you are traveling in a taxi, you get charged with some amount. Now my question is, you get charged with some amount of rupees on the basis of distance or displacement. Do think about that, and I will meet in the next class. That's all. Look, so during the motion and distance displacement for the Chidang motion science chapter number motion reference point chigni object position for example, cell phone cell phone dida ani ngani para tha ringthong di tanda meter ngai na kisi nge komachi jaba ni position chu yala ma motion na yure la or. Understand? So the nature of the motion la ani khaza zinde dumba na motion for jang yure linear motion na circulatory motion, oscillatory motion so na jang yure linear motion na khap tu na chimba pena 100 meter ways and you should be pulled to the big opposite my to do one kadura 200 so you want so the motion shows the linear motion now circulatory motion center point chigni kora jade wa pena provana the urdu la jwa the kind of dinner told me was kora jade la watching judi wa center point ni it kora jade ya mena choose in the minute hand the second hand is kora jade center point chigni kora jade wa circulatory motion wa that's somebody was oscillatory motion na chidangi motion china dena toward and forward motion yuna yamena backward and forward motion yuna also the digital oscillatory motion like example kariore pendulum yu thange this jala kiran so distance and displacement ko ranye kiran so this lami distance na kiran so nam ki dunga ji michi ki khasu doshas langa kali chinshas ode langa chindu samagi length la so khalore distance la ores wa and displacement la na manso mi khaw than mo dosha ti manso la je de mindus manso korne कोई position तंबो द goal start शा अन कोई की final द goal ले शा दिरंगी की बोलो था रुंग शुरू ती मजो कर लगे displacement न मजो था चीनी इस दिके शुरू वा so मजे के खासे ना ला मजे के displacement न direction यो रे लावरे whereas distance ना direction यो मार लावो वा so dos चीने आने में तेरी की लोग जिंदे wind up चीनी अन संगी क्या लेने जायो अन ये द motion भी चक्कर क्या next part is मार किए चीना that's it. Thank you.